In this video, we're going to pick up where we left off last time. So last time we had layer 2 bridging going, we added BGP to the control plane, we had connectivity from a layer 2 perspective. So if you were in the same VLAN, you could talk to each other. What we want to configure now and look at is how to talk between VLANs or VNIs. So, you know, how can the 10.0.0 talk to the 10.1 network, assuming you're in the same tenant? So let's look at our diagram. And in our case, we want the orange tenant to all be able to talk to each other. So we want, and see, PC1 and PC3 are on the same broadcast domain. They're 10.0.0/24, and PC5 is over here. It's on 10.1.1.0. So it's on a different VLAN VNI. So what that means is when we're doing bridging only, they can't talk to each other. And so that's what we want to fix in this little segment. So what we're going to do is get routing going between all the orange. Now, the blue, they're in the same VLAN. They don't necessarily need to route to talk to each other, but we're going to go ahead and set them up anyway to get them ready for in the future whenever we start configuring this right side of the diagram. These PC2 and 4, they're going to need a default gateway to get out of the fabric and talk to other things. But primarily, we're going to focus on the orange here because we'll be able to see it right away. So the concept of what we're going to do here is let's compare this to a traditional network where, you know, normally on Nexus 1 and 2, you'll have all your VLAN gateways or switch virtual interfaces up here, and then these are all trunk links. Well, this changes. In this design, we're going to take all these SVIs and we're going to push them down to the leaf nodes, and specifically 3 and 4 in this example. So let me show you a little visual of what I mean. So what we're going to do on Nexus 3 is we're going to configure a default gateway interface VLAN 10. Now that's going to be in a VRF that we're going to designate to this orange tenant. Now we're going to take the interface VLAN 10 and we're going to also put it on Nexus 4. And so this is what the Anycast gateway feature is called, where we have the default gateway on each node. And yet it is technically a duplicate IP, but the way the fabric routes, it's not gonna be a big deal because the fabric is gonna route typically on host routes, where each host generates its own route in the routing table, and this is a /24. It's a little bit less specific. It won't really cause a problem, but we're also going to configure VLAN 20. There's the default gateways for the blue tenant. And last, for PC5, that's kind of all there by itself. It's going to get its VLAN 11. So again, all of the orange are going to be in a VRF, and then all of the blue are going to be in a VRF. That way we have segmentation of routing tables. So VRF, maybe at a super high level, you could think of it like sort of like a VLAN carves out a section on a switch for maybe a customer. A VRF carves out a logical segment on the router. It's a separate routing table designated on a box for a customer. So a customer in one VRF cannot see or talk by default to another customer that has its own VRF. And so that's the multi-tenancy that's going to be built in here with VXLAN. But this feature is called Anycast gateways, where we push all these down to the Nexus 3 leaf nodes here, and they have the default gateway on them. So let's look at one other concept. This is going to be how it's going to route. And this is called the layer 3 VNI. So we already saw how layer 2 VNI works and how it keeps things separate. Layer 3 VNI is going to be used for routing when we're routing the traffic. So we're going to make a layer 3 interface that's going to be used for routing. And we'll get into the configuration. I'll show you more because it's funner to get into the configuration than do PowerPoints and stuff. But I just wanted to show sort of a a visual of how it's going to work. So that way you'll have something in mind as we're configuring. So how this is going to work is we're going to create the VRF that I was talking about on Nexus 3. And we're also going to create a VRF on Nexus 4. This is going to be for all the orange customers. And then we're going to stick the interface VLAN 10 in the VRF. And interface VLAN 11, we're going to stick that in the VRF. We're going to do the same thing for the blue customer. They get their own VRF. Now how this works from a routing perspective, PC1 will bridge or trunk traffic to the default gateway like normal. It'll hit the Anycast gateway. The Anycast gateway will route it into that layer 3 VNI interface that we'll have. Then it will route it over the VXLAN fabric to be picked up by the other VTAP or the other switch. It'll get picked up by the layer 3 VNI, which will then be routed into the VLAN. So it's going to do a routing lookup here because it knows what routing table it goes in because of the layer 3 VNI that is going to be received on. Then it does a simple lookup to see, okay, which VLAN does it go on? In this case, it's VLAN 11, and then it just simply gets bridged back down or trunked back down to PC5. So looks a little more complex than maybe regular routing, but let's build some of these components just to see how it works. So the first thing we'll do here is let's go to 3. We're going to create a VLAN. This is going to be a VLAN just for the orange tenant. We're going to link it up to be used for the routing. I'm just going to call it VLAN 100. Give it a VN segment of 100,000. All right, now we're going to create the VRF for this tenant. Tenant 1. And here we're going to put the VNI number, 100,000. So here we're linking, this VLAN to the VRF. Now this is going to be important because this is going to be the number that we're going to use to get routes in and out of the VRF. So in Nexus 3 and Nexus 4, when they receive BGP routes, if the routes are tagged with VNI 100,000, it lets the VTAP, it lets the switch here know, oh, it goes in this VRF table. Next thing we can do is, when you make a VRF, you usually have to just tell it what the route distinguisher is. There's an automatic method that we're going to use. What this does is this is a way to keep the routes unique within the fabric, within the BGP table. In other words, Nexus 3 sends a BGP update to 1. It's going to fill in this field, and Nexus 1 would be able to differentiate a packet between any tenants, any and all tenants, even if they're using the same IP scheme. So I'll come back to this in a minute, explain it a little more. But after we create the VRF, we want to create the interface VLAN. And we're going to just put it in the VRF. First thing we want to do is put it in the VRF because when you put something in a VRF, it always wipes the IP address off of it. Now in this case, there's an interesting command, IP forward. So this interface doesn't have an IP address. It just has that command IP forward, and that's all that's needed. That's all you're supposed to put on there to make this work. So this right here is designated. Let me put a description here. Tenant 1 layer 3 VNI. And so this is the interface that's going to be used for routing. So again, PC1 sends it to the default gateway. The default gateway sends it into here. This sends it over to Nexus 4's interface that we'll create. It's going to look the same. Nexus 4 pulls it out of here, puts it in the interface VLAN 11 in this case, and then sends it down to 5. Okay, so let's build these, the actual Anycast gateway. The first thing we want to put is, we have to tell it, so it's a static MAC address. The command to set this up is fabric forwarding Anycast gateway MAC. And then you have to make a MAC address up. So that one looks good. And now let's create our Anycast gateway, and I'll show you how to map this in there. So first, interface VLAN 10. The first thing we want to do is put it in the VRF. Then we can put an IP address on it. And now we link it to that MAC address that we just typed in. And that command is fabric forwarding mode anycast gateway. And then always no shut it. So in other words, this command tells this interface to look for this command and use this MAC address. So in other words, any host we have will be using that MAC address for the default gateway. And the reason we would want this is because if we move stuff around, like if in a virtual environment, if you move things around, the MAC address does not change based on where it goes. It could be in another, move to another switch, and the MAC address won't change. So this is notice this is a global command, but every anycast gateway we use, we want to put this under the interface VLAN. Okay, next would be to, let's look at our NVE interface, and there's one change to this. NVE1, we basically have to authorize that layer 3 VNI to be used on this interface. And the command is member VNI and then our layer 3 VNI associate VRF. Kind of a weird command that needs to be put on there for every tenant we have. So right now we only have one. So we're authorizing the VNI 100,000 to be processed on our network virtualization edge interface. All right, so we need all of this configuration to also be put on Nexus 4. So here I'm going to take the VLAN, the VRF, the interface VLAN, the fabric forwarding command, and then our interface VLAN, and then our NVE1 interface, and just paste all of this on Nexus 4. So this is templatable config, which is good. Now there is one more thing we want to put on Nexus 4 that we don't have to put on Nexus 3, and that's going to be the gateway for PC5. So in other words, we have the gateway for VLAN 10, but Nexus 4 has PC5 on it, which is in a different network. And so we've already made the VLAN for it last time. Here all we want to do is make the interface VLAN. I'm just going to copy some of this. So we're putting it in the VRF and then giving it the gateway 10.111/24, and then we have to put this, linking this to that MAC address we typed earlier. So now there's a default gateway for PC5. And it looks the same as 10, mostly. IP is a little different. But notice they're in the VRF. So in other words, if I do show IP route and look for the VRF tenant 1, I should see all of these things that I've put in the VRF. And this is, in order to get this output, I had to specify what, I'm looking at the routing table, the VRF, for a certain tenant. In other words, these routes will not be in the global table. So if I do show IP route 10.0.0.0, not found. That's because the switch itself, its global table does not know about anything that's stuck in the VRF tenant 1. That's a good thing. That's what we want. Okay, so I believe, we should have connectivity at this point, I think. Let me go to PC1, make sure it can even still ping PC2 since last lab, or PC3, 0020. Okay, it's good. A quick test we could do is from PC1, can it ping the Anycast gateway? So ping 10.0.0.1. So it can. So PC1 is pinging up to Nexus 3 and hitting that gateway that we made. Let's see if PC3 can hit the gateway. Ping 10.0.0.1. It did. All right. And there's on Nexus 4, I don't think we ever configured this interface going down to PC5 to actually be in that VLAN. So let me go to the wiring diagram. Nexus 4. Let's look at it. E15. Okay, so we just want to make this an access port. Interface E15. Switch port mode access. Switch port access VLAN 11. Spanning tree port type edge just to turn port fast on. Okay. Now let's see if what is E1 PC5 can it ping its default gateway 10.1.1.1. Okay, so we have all the PCs able to hit their default gateway. Now let's see if we can route between them. So I'm going to see if I can ping from PC1 to PC5. And it worked immediately. Okay, so let's look at some of the details of how it works. Let's look at the routing table, maybe on Nexus 3. So again, let's do show IP route in the VRF tenant 1. So here we can see I have this, that's my network that's directly attached. 10.0.0.1, that's the specific host of the network that's directly attached. So this is kind of the interface VLAN 10. That's the host. That's PC1. It's directly attached. 10.0.0.20, that's the remote host, and it's learning about this. Notice there's no attached, but there is a BGP. So in other words, Nexus 3 knows where PC3 is, and it knows to reach it over BGP. And it knows to encapsulate it with VXLAN. Now, of our interest, specifically here, is this is the IP of PC5. And it's similar to this one. Nexus 3 knows if it wants to reach 10.1.1.10, it needs to use BGP. And the next hop is 151.44, and this next hop is in the default routing table. So this is kind of a weird way that it works with the VXLAN and encapsulation. Is the next hop is in the default table, but the Nexus knows that. So let's look at the BGP details for this route to look and see how some of these components are working. So I'm going to look at the EVPN route here for this one. I'm going to look at it from Nexus 3's perspective. Okay, so route distinguisher. So remember when we were configuring the VRF, that's one of the things I put in there, RD auto. And the route distinguisher is a value that gets tagged onto the route to make it globally unique. That's the sole purpose of it. And you can see the format is some like value colon another value. And the purpose of that is, again, to make it unique, globally unique. So in other words, tenant 1 and 2 could be using the same IP scheme, but as soon as the Nexus 6 a route distinguisher on there, it will put a different route distinguisher on there. That way the Nexus knows, okay, they're using the same IP scheme, but that doesn't really matter. It's not going to cause an issue. And what else can we look at here? Here's the type 2 route. It's still a type 2 route. That means the next field's 48 bits, which is the MAC address. Means the next field is going to be 32 bits, which is the IP address here. And next hop is the loopback 0 of Nexus 4. We're receiving it from, there's a little bit of a disconnect here, which is kind of how BGP works. It's telling you the BGP update came from 151.2.2, but the next hop is 151.4.4. And that's kind of how BGP works. It tells you what the next hop is, but you don't have to use some sort of certain device to get there. That's a BGP topic. Let's look at these right here. So the extended community, we have a couple route targets. Now the route target has the same format, or a close format, as the route distinguisher. It's a number colon a number. And here it's, it's an IP colon a number. So it can be easy to get them confused, but the route distinguisher, this distinguishes a route. This targets a routing table to put the route in. So in other words, when Nexus 3 or 4, let's say Nexus 3, for example, when it got this route from BGP, it looked at all this. It specifically looked at these route target values. And based on these route target values, it knew which VRF table to put this route in. And how it knew that is, see, this is the layer, you probably recognize it. That's the layer 3 VNI. So there's the BGP autonomous system number, colon, and then there's the layer 3 VNI. And now how did it know? So when it gets a route, it looks at that field, and then, let's see, show VRF. Gonna do a detail maybe, tenant 1, detail. So as soon as it gets a route, it looks at the route target. There's the BGP autonomous system number, and then it looks at this field, 100,000. Then it goes through its VRF tables, looks for 100,000, and here's a match. When it finds the match, it can then import the route into this routing table. And here it's telling you the route distinguisher, which is, this is the route distinguisher, makes them unique. The route target, it's not showing, it doesn't really show the route target here, but there's an route target is also using an automatic method to determine how to mark them and then how to pull them. So let me just show some of my notes on the difference between these. So they have a similar format, route distinguisher. This is how Cisco's doing the auto method. The main purpose is to keep them unique, and here's a couple examples. The first field, see, it says this is the admin field, which is the BGP router ID, and then the numbering field is an internal VRF ID. Now there's a difference between the route distinguisher for layer 2 routes and layer 3 routes. Maybe we can look at this. But the layer 3, it's gonna be look like that. It's just gonna have a number, and that number corresponds to the VRF number. And that's gonna be enough to make it globally unique. So in other words, if that's the loopback 0 IP address colon some value that only one of the tenants have, that's going to be enough to make it globally unique to the whole fabric. Now for layer 2, it's going to start with 32.767 plus the VLAN number. In other words, this right here. So this would be, if we take 32.767 plus the VLAN number, we can tell that what I have highlighted there, it's VLAN 10. And again, that should be enough to make it unique, because you'll have the loopback 0 colon VLAN 10. So there's nothing else that any switch could generate that's going to be the same here, because only one switch can even produce this first field, and then only VLAN 10 can create that last field. So again, the whole purpose of this is just to keep the routes unique. Now the route target controls the importing and exporting of the prefixes. So it's carried in the extended community field. It looks the same, but here we have the admin field again, which is the BGP autonomous system number, and then the tenant VNI, which is the layer 3 VNI. So this is how it knows. So in the VRF, when it advertises routes, it encodes it with that, and it also looks for, it does it in the reverse. When it receives routes, it looks to see who else could be marked with this. If so, I pull it in that specific VRF. So hopefully that makes sense. There are two fields. They have the same format, but they do different things. All right, so I think maybe the last thing we can do is just configure the Anycast gateways for PC 2 and 4. just to kind of go over it again, and it'll have to go faster here. So what first thing we want to do is let's make VLAN 200. This is going to be the VLAN routing VLAN for NV segment or VN segment 200,000. Then let's create the VRF context tenant 2, and then here's where we're going to specify the VNI route distinguisher. We're going to use the auto method. And now let's just interface VLAN 200, stick it in the VRF, IP forward, no shut. Now we can make the Anycast gateways. Interface VLAN 20, stick it in the VRF, and then give it an actual IP address here. And then link it to that MAC address. So fabric forwarding, mode, Anycast gateway, no shut. Lastly, interface NVE1. We need to authorize this on the NVE interface. All right, and then show CLI history, last 20, something like that. And we're going to put all this on 4 because it has a host in VLAN 20. And let's make sure that they can ping it. So PC2 ping 20001. That one's good. And then PC4 well, see PC4 can ping the gateway, and then we should be okay. We should be set now. And then maybe the next video we'll do external connectivity. Maybe let's just look at a super quick Wireshark. Maybe let me start a capture here. See if I can get it between PC1 and PC5. So let's see if this will catch it. I'm just guessed at one of the links. Okay, there's the. Okay, yeah, got lucky. So let's look at the request of this. So these first 3 are sort of what's being carried, the payload. This is the original packet that PC1 made, mostly at least. And then the VNI here is marked. Notice there, that's the layer 3 VNI. And so I took the capture right here after Nexus 3 already modified it. So notice what it did was it stuck the VXLAN VNI 100,000 in there. This way, when Nexus 4 receives it, it's going to look at its VRF table and it'll see a mapping there. Let's see, it's from 3 to 4. Most of this looks the same, but I guess this was kind of the key field. So I think that's all I wanted to show here on this video is just the routing, configure it, how to configure it, verify it, talk about the route distinguisher and the route target and how they're used. And maybe next time we'll continue. There's more on routing we can do when we start to configure external connectivity, like how to get out of the fabric. Because when we're in the fabric, these hosts, they route on like /32 routes. Or what would be specific routes. I guess it's a little hard to tell here, but whenever we generate routes into the fabric, it's going to create a new route type. which is going to be route type 5. We'll look at that next video. It's getting too much. So I think that's all for this one.